The myocardial action potential is what allows the heart to contract in order to push blood out. And so this is going to be the muscle that we're talking about here when we talk about this action potential. And there are basically 5 phases. There's phase 0, phase 1, phase 2, phase 3, and phase 4. And so these 4 phases are basically the phases of the myocardial action potential. And so if I were to draw a graph, it basically looks like this. That is what a myocardial action potential looks like. And you really want to memorize that this is what it looks like, and also the phases. So I'm going to draw at the bottom a cell membrane of a myocardial cell. So this is the cell membrane, and the myocardial cell basically is this entire thing. Okay, so if I were to draw a circle, and then you would of course have muscle fibers running in here that would respond to calcium. But basically this is a cell. This cell is going to be depicted on each of these phases, if that makes sense. So over here is part of phase 4. So during phase 4, the electrochemical gradient is maintained by a sodium-potassium pump. Okay, so 3 sodiums are pumped out and 2 potassiums are pumped in order to maintain a negative internal electrochemical, in order to maintain a negative charge on the inside of the cell. During phase 0, sodium channels begin to open. So these sodium channels allow sodium to go into the cell, thus making the cell more positive. This is why the volts on this graph become more positive. You don't have to know necessarily how positive or negative, but just so if you wanted to know, it starts at negative 85 millivolts down here, and it goes past 0 up here. So what did we just say? During phase 0, sodium channels open. And this is the rapid upstroke that you may hear about in your class. Phase 1. During phase 1, there is a quick efflux of potassium through a channel, and we call that the funny potassium channel, just so you know. And so what this now allows is the inside to become more negative again, because the potassium channel says, it freaks out for a second and says, whoa, we're getting way too negative, we're becoming way too positive, we need to get a little bit negative. And so here, the funny potassium channels open. And allows for an influx of potassium. Phase 2 is the most important phase. If you notice, the cell is now becoming neutral, not changing in charge. In fact, it's becoming a little bit more positive, so something has to be happening. Some positive ion has to be going into the cell, or a negative ion leaving, but really we're only dealing with positive ions. So what we have during phase 2 is calcium ions fluxing into the cell. And now this calcium is what allows for muscular contraction, which is why that is so important. So the rapid calcium influx allows for muscle contraction. During phase 3, the calcium channels close here because contraction is over. Okay, so these close. And now, during phase 3, remember those potassium channels we were talking about? Those remain open and efflux potassium in order to bring the cell back to its negative state. So, phase 3, calcium influx halts because muscle contraction is over, and potassium influx predominates, allowing the cell to become negative again. Phase 4 is the next most important phase. Okay. Phase 4 is the last phase, and we're back to this phase, right? And that is that the electrical chemical gradient is maintained by this sodium potassium pump. So I will type that here for you, is that the electrochemical gradient is maintained by the sodium potassium pump. And you should know that it's 3 sodiums out and 2 potassiums in. And hopefully you were drawing this along with me. If I were to ask you, at what phase does muscle contraction occur? Well, you have to think, what phase does that calcium influx occur? And that's here. That allows for muscular contraction. As you know, we require calcium for contraction. If I were to ask you, at what phase does norepinephrine affect muscular contraction in order to increase the strength of contraction? Well, again, the answer is phase 2. And I will write that here for you. Norepinephrine affects here in order to increase the number of calcium ion channels that are open to strengthen the muscular contraction. If I were to ask you, what is the upstroke or the depolarization phase of the myocardial action potential? That's phase 0. Extremely important to know this phase. Next, we're going to be talking about the pacemaker action potential, and the pacemaker action potential does not have all 4 phases.